Hello, everyone. Thank you for joining this session to talk about DevOps for desktop applications running on Windows. First of all, let me apologize because Oren is not here with me. We prepared this session together, but unfortunately, he had a family urgency, so he couldn't make it. But the content has been prepared from him and myself, and well, sorry, Oren, that you can stay here with me. So let's start with why DevOps for desktop applications. In the past 2-3 years or so, we have seen how companies, organizations, and enterprises take advantage of DevOps practices to be more agile, more productive. However, most of the content that we found and the tools and the best practices are focused on web applications. It's super easy to deploy a web application using containers, VMs, Azure pipelines. But how can we apply these concepts for desktop applications? So I assume that if you are here, it's because you are a desktop developer. Yes, everyone? And probably you are interested in DevOps, right? So today, I'm going to show you a demo application that we created to highlight the different strategies, practices, patterns, tools that we use to accomplish the complete DevOps workflow. From branching, how to manage source code, versioning, building, to build your application, how to deploy. And this is something that is super interesting for desktop applications. There are some characteristics of desktop apps that make them unique in terms of DevOps. And one of the first ideas is that desktop applications require to be installed. So you need to deploy something to end-user machines. And probably you want to have automatic updates as well. So these are two concepts that we are going to explore during this session. There are a few slides. Everything's a big demo. And we will start showing the demo from an user point of view. How is the experience of installing and updating an application when there is any change coming? And then we will drill down in the different tools and technologies that we use to accomplish this goal. We will talk about Visual Studio, that is the tool that we use to create Windows desktop apps. We will talk about MSIX. This is the format to install applications on Win 10. And we will talk about Azure DevOps pipelines. How can you use pipelines to produce your installable packages or your artifacts, and how to deploy those artifacts to Azure. So in the world where we live, we are under pressure. We need to deploy often. We need to make updates as fast as possible and to reduce the time to market. And we want to do so minimizing the failures. But this is a marketing slide, and I don't want to convince anyone about DevOps. I assume that if you are here, it's because you already believe that DevOps is a good thing. So let's go right to the demos. So before we start with the demo, this is an open source repo on GitHub that you can use as a template to customize your own applications. So let me switch the screen here. It was 7? Yeah? This was 7? But it didn't work.
Number 7.
Yeah, but it's not working. Oops. Sorry about that. It was working 5 minutes ago.
We did check it, right?
Yeah?
There we go.
Okay, sorry about that. Okay, so this is our repo. This is a very, very simple app. It's just a small form showing some information about the package. And first thing that you will notice is that we have 3 different channels. And this is the first concept that I like to introduce. If you want to deliver fast, probably you need the ability to deploy different versions of the same application at the same time. We call these channels. You have seen channels in Visual Studio where we have the preview channel. And these channels need to enable the side-by-side application running. What it means that I can run different versions of the same applications from different channels and at the same time on the same machine. So I'm going to show you how can you use MSIX to create side-by-side packages. So we started with 3 channels. We have the continuous deployment web. This is an Azure website environment where we deploy almost every commit that we have in master. Then we have the second environment, that is production web. This is hosted on Azure blob storage, and this is where our end users will install the application from. And we could also deploy the application to the store if you want, but today we are going to focus on non-store deployments. So let's see how is the user experience to deploy one of these applications. So first we have this URL, that is the URL that identifies this channel, this environment. As I said, this is an Azure website. And when users click this button, they will see this application. This is the app installer application. This app comes with Windows 10 and knows how to install and how to keep your application up to date when there are updates available. So now I'm going to hit install, and I'm downloading the package and installing the app. And here is my app. It's a very simple app. It's a WPF running .NET Framework that is showing the package name. Note how in the package name I included this CD mark to understand that this is coming from my continuous deployment environment. I have the package version. I can query what was the URL that I installed the application from, and the assembly version, including the Git commit. And as you can see, this is running on Framework 4.8. Okay, so let's play the role that now I'm a developer and I want to make some changes to this application and see how those changes will be delivered to end user machines. So I want to do 2 things. First, change this yellow. I don't like yellow. And second, looks like this string, it's not formatted correctly, so let's see if we can fix the layout. So I'm going to use Visual Studio. This is Visual Studio 2019. This is one preview, so hopefully there will be no problems during the demo. So let's start changing the color. Here I'm using the SAML designer. I can click on the element, navigate to the element, and let me ask the audience, any color? Purple? Let's do purple, sure. Here we go. And this could be white. All right, so now I can run the application to see that everything works as I expect. Note that the only project that I have in my solution right now is the WPF project. What it means that I'm running the application and package. I'm running the exe file. That's the old way of running applications. Oh, I forgot to change the layout. So now I'm going to use one feature that we have in SAML, and this is not DevOps, but it's the way SAML developers work. That is the edit and continue or hot reload, where I'm able to make changes to the application while the application is running. So I can position exactly to the tree where I am. In here, I want to use the install from, and I'm going to add the text wrapping. And here in the IntelliSense, note how writing just TW, I get the text wrapping and start with no wrap. And I'm going to try to accommodate both windows so you can see how we can change the application in real time. So let's see, let me make some room here. Here is the application that I'm debugging, and I want to change this, oops. Wrapping to wrap. Oh, it was not, it's here, sorry, I missed the place. It's the install location. So now I can see the wrapping, and probably I need this label to be centered at the top. So here we go. So this is the application that I want to update. So next step is to commit these changes to master. Probably you can use another kind of submission validation like pull requests or things like that, but I want to live dangerously, so I'm going to commit to master directly. and that's it. And now, let's talk what's happened next. So now that I'm submitting this commit, what will happen is that my continuous integration build will start. This is an Azure DevOps pipeline that will check my commit. And this pipeline is executed every time there is a new commit or there is a pull request. Let's go back to the repo. It's here, and if I go to commits, I can see all the different commits that happened before. Some of them were succeed, some not. And this one that has this little dot, that it means that there is a check that is happening right now. And this is my continuous integration build. This is completely automated. Anyone that did anything, just committing the version. So now let's explore this build, what is happening here. And first thing you notice that we have 3 elements here at the left. These are the artifacts that will be produced for each of the environments. And this is very important. We are producing the artifact for the 3 environments for every single commit. Of course, we are not going to deploy all the versions to production, but we want to be able to test and validate each commit in our continuous deployment environment. Someone will say, oh, but you are building 3 times. It will take 3 times more time to complete. But here we are using one nice feature of Azure DevOps that is the ability to run concurrent jobs at the same time. And for all of public projects, you have up to 10 agents that you can use to build concurrently. So probably all of the 3 will end at the same time. And each of them is producing a different set of artifacts. And why the artifact is different. We deploy desktop applications with installers, with packages. And each package needs to be self-contained. And we don't want anyone to modify our packages. However, there could be some differences between one package for each channel. Just things like the title, or the display name, or the app identity. For example, if we want to submit to the store, the format or the file that we use to submit to the store is a special file. So let me check the artifacts that have been generated here. Come on. You're waiting for the last one to complete. So the other 2 channels, the CD web and prod web, they both share the same kind of artifacts. So here we have the HTML page that you saw before, the app installer file, this is the file that is used to manage how updates are delivered to end users, and the package, the MSIX package that will be here. In the case of the store, we have only the MSIX upload file. This is the file that includes the symbols and everything to submit to the store. And then we have this summary page where we can see the releases. So we configure our release pipeline to start the deployment every time that the build from the continuous integration succeeds. So now we started the deployment to our CD web. Remember, this has been automated. Anyone made any manual step to get this application deployed. So now it's updating the package to Azure Web Applications, and when it's done, the update will be available for every user. So here, the idea is that it should be as simple as updating a web application, where users go to your app and they get always the latest version. So now, if I go back to the HTML page, I should have the next version, should be, which one? 21. So I refresh, 21. Of course, if I click install, I will get the update, but I want to show you the new experience and how applications deployed with MSIX can get automatic updates like this. So now the first time that I'm going to open the application, it's going to run the previous version, but then it checked in the background if there is a new version available. So now if I close the application and run the application again, you will see how the application updates. Okay, demo effect, one more time. Oh, come on. Oh, I know what happened. The application was open, so it was not able to update. So let me close one more time. And now you see that progress bar that happened super quick, and now I have my application updated. So think about this. What we made here, it's something that is super cool. It's just let developers make commits, and all my testers can have the latest version without any manual intervention. So let's review how all of this was possible. So if you want to try to duplicate the same workflow for your desktop applications, you need to go through each of these steps. So I want to make sure that we share what we learn. I learned with Oren preparing this demo, and some recommendations and guides or tips and tricks that you can use to apply this to your apps. From source to release, and how to measure quality with test, telemetry, branching, when to sign, and everything in between. So let's start with branching. Branching is one of the initial concepts that you need to define for describe your workflow, your DevOps workflows. There are some people that are very opinionated about this, and they have different versioning schemes based on branches. The bottom line here is that we believe and we recommend what we call the release flow. This means that everything lives in master. We have branches that are small branches that we use to fix bugs or to add new features, but everything is merged back to master. The important concept here is don't try to create channels or environments based on your branches. Branches are used for improve how developers work together and how to manage versions and changes, but doesn't need to accommodate to your release environments. If you want to do what we call environment promotion, that is that I have this version and I want to move this version from test to QA to pre-production to production, and you should be able to do so without creating different branches for each environment. The last thing that is interesting is how can we version our applications. The version number is super important. It's something that we need to correlate problems, to be predictable, to be able to reproduce issues when they appear. And there are different techniques to define your versioning scheme. Sometimes users define the versioning scheme based on the build number, but it's weird because there's some places where I can build a lot of times from one branch and not for the other. There are other approaches using the different branches to produce the version, but branches can change over time. And we like this NerdBank Git versioning. It's a NuGet package that allows you to configure your version numbers based on two things. One is a seed. It's a file that you add to your repo with them, saying that this is 1.1. And then the other number, it's calculated based on the number of commits since the previous build. What it means that the build number is identical on all the branches that I can have. So if I branch my code, but I didn't add another commit, the build number should be the same. So this is what we are using here. The next concept is MSIX. MSIX is the deployment format for Windows. Previously, we used to deploy Windows applications with different technologies. How many use MSI? Some, a lot of people. Click once. Xcopy? No one? Oh, some people use Xcopy. Okay, each of these deployment techniques has some challenges. And with MSI, how to do updates is not built in. So there are some third-party products or there are some approaches, but automatic updates are not there. Also, how to produce MSI files from your pipelines also has some challenges. Sometimes you need special tools or you need special SDKs. So producing MSIs is not an easy task. I'm not saying it's impossible, I'm saying that it's not easy. Click once, it's super easy to produce auto updates. However, if you want to produce different channels or be able to have side-by-side operations, that's not so easy. So how to do each of those? If you go with the Xcopy, okay, it's super flexible, but how do you handle updates? With MSIX, we get all the benefits from the different deployment techniques that we have and put all together in this package format that solves different problems. The first one is that reduces the chances that your system will get corrupted, or the WinRot problem when you install applications and uninstall applications. How many times do you say, I'm going to install this app? No, because maybe my system will not be the same after I install. With MSIX, we guarantee that when users uninstall the application, the system is exactly the same as before the install. There are a number of technologies involved here, like virtualization of the registry, virtualization of the file system, and all of this comes for free when you deploy with MSIX. MSIX started with UWP and applications to be deployed to the store, but now you can use MSIX for any Windows application. When I said any, I mean any. This could be MFC, C++, UWP, .NET, .NET Framework, .NET Core, or even applications created with another IDEs different than Visual Studio. Because the MSIX package is just a zip file, well, really it's an OPC file that is based on zip, that includes a manifest that describes your application. And this is super important if you want to modernize your app in the context of Windows 10. So if you want to take advantage of some of the Windows 10 features, like add remove programs, or you want to integrate with the notification center, or you want to integrate with Windows Hello, or use the new SAML islands, or there are a number of places where you will need to describe your application identity, so the operating system, Windows, can interact with your app in a better way. The next benefit of MSIX is that with the same format, you can deliver, or you can publish your package to different places. So you can use managed environments like the store, Intune, or configuration, or the CCM, where you use MSIX to deploy the package there, and the updates are managed by the system. But also unmanaged scenarios where you customize where do you want to deploy. We have seen that a lot of enterprises, they don't want to publish their applications to the store, but they want all the benefits that are provided for store deployments, like automatic updates, for example. These custom locations could be shared folders in your private network, could be web locations, like I showed you before in the demo, and these are managed with this app installer file that I'm going to explain later. And what is new for MSIX, and we got a lot of questions in the desktop booth during these 2 days at Build, is what's happened with .NET Core 3 and click once. So for .NET Core 3 applications, all of you are familiar with .NET Core 3. It's coming to desktop, WinForms, WPF. This is the new version of desktop frameworks running on .NET Core 3, and the deployment option, the preferred and recommended deployment option, is going to be MSIX. And .NET Core 3 has a couple of benefits here. One is that you can create self-contained applications, so your application can be deployed anywhere without requiring to install .NET before. But also you can configure framework-dependent deployments. And where do you install your application? Because it looks like MSIX is Windows 10 only. So luckily we have MSIX Core. This is an open SDK that we are producing on GitHub to enable MSIX packages to be deployed to all supported versions of Windows, from Win 7, Win 8, and all the versions of Windows 10. We call it MSIX Core because it does not have the same features as MSIX, so some features that are unique for Win 10 won't be available on Win 7, but if you are delivering a Win32 or .NET Framework application, you can use it to deploy to MSIX Core. This is open source. If this is important for you, please file issues and take a look to this project. Basically, it will be like the last MSI that you install in your Windows 7 machines. This is an MSI that will include the ability to deploy MSIX applications. And looks great, right? The MSIX story, it's promising for desktop developers, but how desktop developers can create MSIX packages? So we added this feature to Visual Studio through the Visual Studio Windows Application Packaging project. This is a project type in Visual Studio that is super simple because it's not including any code. What it's doing is just guide you to design and author your package. This is an MS Build project system, what it means that it's super easy to integrate with Azure DevOps. So if you need to pass some properties to MS Build or you want to customize anything in your build, you can do it from MS Build. So command line builds, of course, work as expected. And if you want to use the packaging project, it's available in the UWP workload. This means that you need to install not only .NET for desktop, but also the UWP to have access to these tools. The reason is that there are some tools that we use to produce MSIX packages that are, for example, Make Apex, Sign Tool, Make PRI, that are available in the Windows SDK, and the Windows SDK is installed with the UWP workload. So let's take a quick look at the packaging project. So here I have Visual Studio, and what I want is to create a package for this application. So I need to add a new project to my solution. This project is the packaging project, that it's here, and I'm going to give it a name. Make sure that I don't have anything here with the same name. And the first question is, which is the versions of Windows that you want to support? Let's say yes by default. So here's the packaging project. And basically, it has three things. First is the applications that you want to deploy. You can deploy more than one application if you want. We want to deploy this WPF app, so we add a reference to this project. We have some images to customize how the application will look like in the start menu, in the action center, and any integration with the OS. So let me show you the package manifest and how can I customize these visual assets. So I'm going to select some pictures like this one. I want to generate all the scales for different form factors. So you will see here that this wizard generated all the sizes for my tiles. And what is interesting from the manifest is this packaging tab. Here is where we define the application identity. This is where the place that you need to change if you want to install the application side by side. Here I'm going to call this my package. And one recommended practice is to don't include your production name here, because when you have the production application installed, then you can't install this one. So what I'm doing is by default, I'm using this local, like it was like localhost for web developers, and then I replace this before I produce the production package. It's also important to choose the certificate that we want to use for sign-in. So I'm going to use this test certificate. And I also like to add the certificate here to the publisher name. And also take a look at this package family name, because this is something that we are going to use later. So now, if I run the application, instead of running the application from the WPF project, I'm going to run the application from the packaging project. And there will be a couple of differences here. So now it's building, it's producing the package. So the first thing that happens is that the application is running on the context of MSIX. It means that it uses all the images that we just configured. So if you look at the icon that will be shown here in the taskbar, you will see that the icon is different because it's the, I don't want to debug everything. Come on. So here's the application, and you will see that the icon is different. Now the application is packaged. So I have a package name, I have a package version. However, this application is installed directly from the MSIX, so we don't know where the application will get updates. So this is the packaging project. So let's move on. So now that we know how to get the sources from source control and build, let's talk a little bit about the agents. Azure DevOps pipelines have two options to produce builds. One is the hosted build agent. This is a great option. It includes all the tools in Visual Studio. with all the features. So if you are using the default Visual Studio, you should be able to use this agent to produce your builds. It also includes the packaging project, of course. It can be extended with new SDKs. So if you want to target the SDK for insiders that has not been released to Visual Studio yet, you can customize. The Windows Community Toolkit has a great PowerShell script that you can use to download the ISO and install the ISO in your hosted build agent for each build. And something that is new with the hosted build agent 2019 is the ability to run tests. Here, I'm not talking about unit tests. Unit tests is a common practice for DevOps, so there's anything new here. What we want to run are UWP unit tests or Code UI unit tests. So that's something that was not available before, and I'm going to show you later how to run automated tests. And the great thing about the hosted build agent is when the build completes, the virtual machine that was used for that build is thrown away. So you don't need to worry about some secrets or anything that could be left on your build machines. The other option is the private build agent. The private build agent is a machine that you configure. You have control over that machine, patching, updating, everything, and you can customize it as you want. There are some reasons to use private build agents, although we recommend hosted build agents when possible. The first thing is what's happening if you want to deploy to your private share, to your private network. Maybe you want to run with an agent that is in your private network, so that's a good reason. Or maybe you want to speed up build times. If you need to install the SDK every single build, it's going to slow down your build time. So if you have everything configured on your private build agent, it will build faster. Or maybe you want to install custom SDKs. But something that you need to consider if you decide to go with a private build agent running inside your network is that be careful if you accept pull requests from untrusted authors, because then you are downloading code that you don't trust and running that code inside your network. So be careful with that before enabling private build agents. My demos and everything that I'm doing today is with a hosted build agent. So everything that you see here, you can do it the same with your application. And how the build is configured. How do you define which steps or which parameters do you want to use with your build? So we have this new feature called a YAML file. This is a file that you commit to your repo, lives with your branches, and this file will define all the different tasks that need to happen for your build. So let's take a quick look at the YAML file. This YAML file is available in our repo, and I encourage you to clone the repo and use this file as a template for your own applications. So let's take a quick look to this file. So here, I'm going to navigate to my builds. I'm going to edit this build definition, my CI build. So this file lives on GitHub, but I'm editing the file from Azure DevOps. The reason is that I have this handy toolbox where it's super easy to add or remove steps. So let's comment what is in here. First, we define the trigger. Where do we want to start the build? So every check-in that happens in master or any branch that starts with rel will produce a new build, except if it's a markdown file or the UI tests. The same for pull requests. And we have just one job, and that is called build, that is running the hosted build agent. And this is what is super interesting, is how can we define this matrix of different channels. So we have the CD web, where we define the URL where we want to deploy, the package ID, this is the identity of the app. The same for production web. However, for the store, we don't need to define that URL. So here are the parameters that we use to produce these 3 artifacts for each build. And then in the steps that I have, I'm using the .NET global tool to install NerdBank Git versioning and set the version. So this version number that is calculated at each build is part of the build number for the build. And then I'm using this PowerShell script to customize the manifest. And here is where I set the identity, the version, And I run this PowerShell script with different parameters, so this is how I customize the difference between the artifacts per channel. And something that maybe, well, that's a common question that we got is, how can we configure configuration for different builds? So sometimes you need to configure your dev environment different than your production environment, maybe the debug level, or there are some configuration settings that are different. So that's something that you must do before you create the package. So here what I'm doing is configuring application insights. That's the tool that I use to collect telemetry to change by environment. And then finally calling msbuild, and I'm calling msbuild on my solution, and I pass some parameters here to customize the build. And finally, I copy the certificate. I will explain why I'm doing this later, and publish all of these artifacts. So these are the steps that you saw here when we were reviewing how our build works. So we can inspect any step and all the build logs that you have here. So that's enough for builds. Let's go back to the slides. And now that we have our artifacts, we want to talk about how can we distribute these artifacts. I mentioned that the store is a great place for consumer apps. Everyone knows what's the store. It's available in Windows 10, so you can download apps from here. It handles how to sign your packages, so you don't need to worry about certificate management or anything like that. You submit your package to the store and the package gets signed. It also has a nice feature that is called flights that allows you to submit a version that will be distributed to a small number of people before you distribute to everyone else. And the auto updates are managed by the store client. So everything there is in a version, you will get the store client. But today I want to focus on non-store distribution. So if you decide to go with non-store, there are some options, like if you want to distribute in your private network or web. But the first thing to understand that it requires a trusted certificate. It means that all MSIX packages need to be signed. Windows is not going to install any application that is not signed, and must be signed with a certificate that is trusted on your machine. So if it's a certificate from your company, from your private CA, and that certificate is already trusted on end-user machines, you are good. If you want to distribute to unknown users or outside of your enterprise network, you must use a certificate issued by a public CA. There are some cases, for example, for testing, where you can use self-signed certificates. That's the case of the certificate that I'm using here. Next thing to consider if you go with a non-store approach is how to define your update policy. What you saw here is the default update policy, where the application will check for updates after the application launches, but there are some cases where you want to block the application. So if there is a new version on the server, make sure that anyone will run the previous version until they got the update. You can define that kind of policies. Or maybe you prefer to update with a background task every night or every morning or whatever. All of this can be customized with the app installer file, where you can configure your update policy. And this is a great option for enterprises if they want to distribute applications outside the store. There are some cases in the middle where you as a developer can use the Windows packaging APIs and create your own solution. So you can host in somewhere what's the latest version, what's your latest package, and call these APIs to force the update. So remember how important it is to define your application identity to be able to run side-by-side version of the same application, even if it's in the store or if you are using side loading only for testing. And to configure updates, we are adding a new feature to the packaging project that will be released in the next version of Visual Studio. Everything that you saw in the demo, by the way, it's available today, but this is something that is coming. I will talk about the roadmap at the end of the session. And this is a template that you can use to customize your settings. So here's where you can see the update setting on launch, where we are saying that we want to update blocks activation. So let me make a demo of the app installer, not with Azure, but just locally, so you can see how this process works. So first, I have here a shared folder that I can use. commands, apps, my package. Let me delete everything here. Oops, sorry. So I have here a shared folder that is locally on my computer, but you can think that this is a shared folder on your intranet. And what I'm going to do is to add the app installer file. This is a new template that we have here, and I want to customize how the application will be installed. So I'm going to use a feature that is available in the latest schema. That is the show prompt equals true and update blocks activation. This means that if there is an update available, block the activation until the app gets updated. Thank you. That's it. So now I'm going to run the packaging wizard. This is another feature of the packaging project. It's the same wizard that we have in UWP projects to produce my artifacts from Visual Studio. So here, the first thing that we ask is, how do you want to distribute your app? Do you want to distribute in the store, or do you want to distribute in a non-store environment? So I choose non-store, and I want to enable automatic updates. If I enable automatic updates, I need to specify where do I want to get the updates from. This screen is to define the bundle, different architectures. Because I'm running .NET Framework, I can use the neutral architecture, and I'm going to specify the folder where users will get the update. So now I'm building, creating the package. We are signing this package with my test certificate. And when everything is done, we show a dialog showing the package that has been generated. And we added this small feature where you can copy the output from this folder to your shared folder. So I copy this thing. So it's already copied, and I have here my HTML, my app installer file, and my package. So let's install this application. It's the same application that we created again. Oops, it's already installed, so let me uninstall first. It's installed because when I run the application from the packaging project in the previous demo, it also deploys the app. So now we can see this app. And now we have the installed from URI, that before it was empty, because now I'm installing from this folder. So now if I make any update to the app and publish the package again, let's say I'm not going to do any change, just compile a new version. Notice that this check automatically will increment the version number by 1, so now I have 101. And now when I try to run this application again, you will see a new UI that the application will be blocked because there is a new application on the server. So copy, it's there, and now if I run my application, you will see this UI. This is the update policy where we are forcing every user to get this update. And if they don't get the update, the application won't open. So I update, and now we will have the version 101. And it's here. Thank you. So going back to the slides, let's talk a little bit about signing. First, why signing is so important. We know that deploying binaries to end-user machines, it's a challenge. It's a challenge because we are copying binaries that could have malware, could have viruses, not because we introduce viruses, sorry, it's because someone can modify our package. We have seen these kind of attacks everywhere, where we have from rootkits, or someone that intercepts my installer, changes the installer, and then all my users are infected. Digital signatures allow us to control and avoid this situation. So when you sign your package, what we get is that the package is protected for any change. So if anyone tries to modify your package, the signature will not be valid, and Windows will not install your package. So this is the first check, that is the content integrity check. The second check is the proof of authenticity. With public CA, with CA certificates, CA-issued certificates, we can trust that the package was produced by a given developer or a team or a company. So with public CAs, you can enable wide distribution. So if you have a certificate from DigiCert or Symantec or any other CA that is already trusted in Windows, all your packages will be trusted. If you are in a company, you can use your private CAs. Self-signed certificates can be used for testing or development, but they are not intended for production usage. So we recommend to control how to use these self-signed certificates. In fact, this is a change that we are adding to Visual Studio to reduce the number of certificates that you will see when creating UWP or MSIX packages. So only if you decide to go with non-store distribution, we will ask you for the certificates. Otherwise, we manage the certificate internally. Remember that the subject name in the certificate must match the publisher string in the manifest. So this way we can control which certificate is used for each environment. And as I said before, you don't need a certificate if you are not planning to do sideload deployment. So F5 doesn't require a certificate, deploy to the store doesn't require a certificate neither. And what is the right place to sign? Because we used to sign for every build, but then we realized why. We are adding that requirement to deal with certificates. So now by default, the builds will be unsigned, and then you need to decide when do you want to sign. And we came with this idea that signing could happen at the release time. So if you are using release pipelines, you can control how do you sign at this stage. So you don't need to share the certificate with the developers, or saying better, you don't need to share the private key of your certificate to your developers. Remember that before I told you that I'm copying the certificate here and there, is because the private key is something that even I don't have the private key of this application. It was configured by Oren. What I have is the public key of the certificate. So as a good practice, what we are doing is switch to see the pipelines. So what we have in our repo here is the public key of the certificate. So anyone who trusts this repo and want to install our test packages should add this certificate to their trusted local machine, trusted people certificate store. And for signing, as I said before, this happens in our release stages. So let's review our release. And in this stage, that is where we deploy to our continuous deployment environment, I'm using this task, code signing. This task uses a couple of nice features. First one uses secure file. The secure file is something that you configure here in your library of releases, and this is the PFX file. The cool thing about the secure file is this is a file that you can submit to the system, but no one can download it. Only the system will use it to sign. So I can download this file. So it's not perfect, but it's good security approach. And also we have this variable with the password of the certificate. So only users who have access to our release pipelines can produce signed packages. Let's go back to the release to see the next thing that we have here is the deploy to Azure App Service. And here, deploying is as simple as deploy any other app service application. So it's just copying files to your web location. So here I'm using Azure Resource Manager, and this enables to query all my subscriptions. So I'm using my subscription, which app service type. This is a web app on Windows, but could be on Linux or anywhere because we are not running any code on the server, and what's the app service name that I'm running. And then I'm using this virtual application, so I can use the same web application or site to deploy multiple channels. Let's take a look at how it looks on Azure. So I'm deploying to this WPF web app that is running on the app service. And the only thing that I needed to configure here is the path mapping. So I have this virtual path, the continuous deployment, pointing to this location. There is one extra step here that is to enable the MyMed types, so the .msix extension is recognized by the web server. I will add some, there are some links at the end of the deck if you know how to configure the thing. And also the other thing that's super cool is that you can see this tab, the deployment center. This is the Azure portal, and this is querying all the releases that were produced by my Azure DevOps pipeline. So everything is integrated here. Before we were seeing how things look in the pipeline. Now here from the portal, I can see the different releases that we have here. So if we go back to the release pipeline, we also have the production web. As I said before, this is deploying the artifacts to storage. What I have here in storage is storage account with blobs. And I'm using this nice feature, the static website, that this enables to host files on any blob container. And this is the URL that we use for production. If we go back to see our pipeline, here we have one different step to deploy the MSIX, the certificate. This is the public key of this certificate, the app installer file, and finally the index. And notice here how we are setting the MyMed type of this content type, of the, to understand what will be the content type that is handled by browsers. So now let's release something to production. So now I can see all the different releases that I have. I can see the releases that have been deployed right now. Oops, sorry, I need to select this one. I have these two releases deployed, or I can see all the releases that happen. As I said before, all the commits to master are being deployed to CD web, but only a few of them are deployed to production. If I want to release to production, I have this manual approval, so I'm going to approve this one, and it's going to be published as we speak. Something that I want to highlight about these releases is that you used to deploy from master, but you can deploy from other branches as well. So here you can see how you can deploy from this branch, or even from a PR if you want. So you can customize which build do you want to release, no matter from which branch it was produced. And this is possible because we have the artifacts for the 3 channels on each build. Okay, so we are promoting our production version, and we didn't talk about testing, right? And I know that everyone doing DevOps, they are, hey, what's happened with the test? That should be automated and should happen here. So the good news here is that I'm going to show you how you can run UI tests. We all know about unit tests. As I said before, it's not because they are not valuable, it's because there's anything new or unique about desktop applications, but running desktop UI tests, that's really unique. So we are using WinAppDriver. This is a tool that was created based on Selenium. It evolved to Appium, and finally to desktop to create some basic scripts to automate the app. So let me show you this demo. So I'm going to open the project that I have to run the UI tests. So here we have this concept of session. This is how I locate my application. Remember when I showed you the package family name in the manifest editor? This is where you can get this string and then bank up. And this is the magic string that we use to launch our application. And then in our tests that they inherit from this session, you can do things like find an element, and assert if the type of element is a button or not, or what's the value of the string. So this is the test. It takes a while to set up all the infrastructure, so let's review some of the tests that already ran. My tests are configured based on dependent builds, what it means that every time that I have a build here on my CI build, it will start another build for my Windows WinAppDriver tests that are here. And here I can see that my test is failing. This is intentional. I think that tests have more value if you understand how they fail, rather than if I show you that everything is green. So let's see if we can investigate what's going on here. So I'm going to run this build definition that has some tests here, and you can see that I have one test that is failing. If I click here, I will see the effect, the assert that is failing, and this is the framework for 8 was not found. So remember that when I run my application, I see that this is for 8, so I'm pretty sure that it should work. So what's happened on my web server? So I'm going to use a nice feature that is the ability to record what is happening in your UI tests. So now I'm going to download a video that was recorded on the hosted build agent, where I can see how my test script was exercised in my UI and see what's happening here. So I'm going to download this video. This is screen capture. I open the video. Look, that this is the purple that you select, so this is true, it's not fake. Oh, and what can I see here? This is 4.7. This is because this is running on Windows Server, and this version of Windows Server is running on .NET Framework 4.7, and this is why my assert is failing. So now I know how to fix it. And again, all of this is available in the hosted build agent with the WinAppDriver, and you can run these tests super easily. And you can find these test scripts in the GitHub repo as well. And now the last part that we want to talk is about telemetry. And what is important about DevOps is that we want to measure quality all the way, starting from devs, the builds, the test, but also what's happening on production, how our users use our application. So we are using application insights to define this application. This screenshot is from NuGet Package Explorer. NuGet Package Explorer is an open source tool created by Oren, and he instrumented this application with App Insights. And we thought that it was interesting to see real telemetry from a real application with thousands of users to see what kind of things you can get from App Insights. This is my last demo. So let me switch here. So this is the NuGet Package Explorer site. We have like 11,000 distinct users with 700,000 events in the last 30 days. Some things that you can do is that you can split by application version, so you can understand how users are getting the latest version of your app. Oren released a new version last week, so you can see how this new version has been installed in a lot of machines. So right now, this version, the 5.2.15, is the latest everywhere. You can also split by environment. So here you will see which is the preferred channel for NuGet Package Explorer. So this application is being delivered through the store, but also as a zip file or Choco or any other release method. And for our application, let me go back to the app. We are using this diagnostic client that is based on a NuGet package provided by Oren. Is this one, the App Insights Windows. And here, basically, what we are doing is at the starting of the app, we initialize the diagnostics client, and then in the app itself, we are calling the track page view or track event here in the code. So with these 2 lines of code, we can get things like, let's go back to our source group, open my App Insights, and you can see the events that we have. And you can see more insights, the events that we are tracking. So it's super easy to instrument your application. And just with a few lines of code, you can get something like this. This is also a feature available in App Insights that gives you the user flow. So how many users start in the main window, how many went to this step. This was the second step, third step, and there they finished the application. So the user flow, these are the kind of insights that you can get from your application when running on App Insights. And we are running out of time, so to recap, remember the steps that you need to go through if you want to duplicate this in your application. So you need to talk about branches, packaging, build, sign-in, distribution. With MSIX, you have the format to target any Windows machine. And just sharing some ideas from the Visual Studio roadmap. Late this summer, we will release the version of Visual Studio that support self-contained applications for .NET Core 3 apps. That's a key concept to modernize your apps. The new certificate management UI in Visual Studio, that's also coming with the same version. How to update the manifest from MS Build to avoid that PowerShell script that we were using, and the app installer templates that I show you. And from MSIX Core, we expect to have a release for Win 7 later this summer, and the final version will be later this year. And we will support enhanced deployment for Win 7 as well as auto-updating. So for you, the call to action is use Azure DevOps to deploy your applications. It's super easy to use YAML files to customize your builds. Use the packaging project to produce MSIX packages so you can target a lot of machines super easily. And choose the best distribution option that makes sense to you. If you prefer non-store or a store location, anything is good. WinAppDriver, it's a nice tool that you can use to automate your UI tests. And finally, don't forget to instrument your application so you can get good insights about the app. So that's all. Here I have some resources, so if you want to take a look or download this deck, you will get this thing. And here there are some related sessions to this, but a lot of people were taking pictures of this. Yeah, so that's all. Don't forget to complete your evaluations, and thank you very much. If you have any questions, I'll be around.